Good morning. Waking up. Welcome to DevCamp. Bryan just said this is the first ever DevCamp in person. And so we have only one time to make it a great event, and next time we will have to live up to the expectations from this one. It's so great to be here. I'm Thomas. If you haven't met me before, I'm the CEO of GitHub, the chairman of Wilderness Labs, but most importantly, I'm a developer. I was born in the late 70s, around the time when the Commodore PET, the Altair and the Apple II became more popular, right? A time that was very different than it is today. I started coding in 1989 on a computer in school. At the time, my parents' household, I think, had no connected device other than a landline phone. And the only device that ran software was a calculator, a Russian calculator with a nice LED display. And the world since then has dramatically changed. Imagine the last 3 years, the pandemic, without any software. Imagine what that would have been like, to be on landline conference calls all days. I'm pretty sure most of us would have just quit our job and went to the woods and enjoyed life there. Our personal lives, our professional lives are now dominated by software. Even our nights are dominated by software, sleep tracking on your watch. In the morning, the first thing I do is grab my phone and check messages on Slack and then check email, photos from my family in Germany. My employees, my team members, my bosses all ping me on communication. My thermostat is, my lawnmower is running on software, right? Connected to the internet with GPS. My car is running on software. In fact, would you open a bank account if the bank doesn't give you a good app and a good online experience? Probably not. Every company is now a software company, and they have all realized that they need to invest into software. And not only is software changing, we have now all these connected devices. In fact, we're predicting that in 2030, there will be more than 50 billion connected devices. That's 20 or so on average per household around the world. On average, 20 connected devices. Bill Gates had that dream in the 80s of a PC on every desk in every home. And he couldn't have imagined that now we can take much more powerful chips and put them in devices that are as small as a fingernail. And all these devices need software, and all of them collect data. In fact, I saw a blog post last night that estimated that in the last 20 years, we wrote over 2 trillion lines of code of software. Somebody needs to maintain all this, right? Somebody needs to make sure that that software survives. When I speak with banks or financial services companies, most of them tell me that we're running COBOL from the 60s on mainframes. And I'm like, 60s, you sure? Yeah, 68 is what they're still running today. And so whether it's the challenges of today that we have to solve or the future of tomorrow, we need a scalable, a secure, an enterprise-ready platform for all these internet-connected devices. We need a developer platform that keeps us sane, that keeps us productive, that keeps us happy. And I believe, Wilderness Labs will deliver this platform. We will make sure that no matter what device you're developing for, you have everything you need and you can stay productive while you're doing what you love doing, which I think for all of you is coding. And so with that, I'm really excited to be here today, and I'm giving the floor to Bryan Costanich, CEO of our company.
All right. Thanks, Thomas. All right, okay. Fantastic. Everyone, can you hear me okay? We got the mic going, rad. All right, thanks, Thomas. Thanks for that intro. Yeah, I'm really excited to be here today. It's been a long time in coming, and the last few years we've sort of been hiding out, afraid in our homes, and now we get to come back together and have an in-person event. Is pretty spectacular. So thanks for everyone being here. Thanks for everyone joining in on the live stream. And yeah, I'm just excited. I'm excited for all the announcements and cool things that we got going on today. We started this company back in 2016, and we've come a long way. The first 3 years of the company we spent in stealth. We didn't really tell anyone what we were up to. We knew this would be a hard problem to solve, and really the worthwhile problems are the ones that are the hardest. But we had no idea, I think, none of us had any idea just how hard of a problem this was. Just how I would say opportunity rich the embedded world is, right? And a few years ago, some of you know this, we ran a Kickstarter, and we blew it out of the park. Thanks to everyone, all of our backers. And we've been in beta ever since on Meadow. And you know, it's been quite a run. We actually, like all good startups, we started in a garage. This was Karina's garage. That's Jorge and my co-founder BK. We were fulfilling Kickstarter orders out of this, and then we upgraded to a storage unit. The storage unit had no heat and no bathroom, so that was interesting. It's at the base of Mount Hood, so in winter it got very cold in here, just above. Sometimes we could keep it just above freezing, and now we've got this massive office, and just really excited to have been part of this growth. And in the meantime, the industry has really radically changed as well. So, you know, IoT is interesting because it is a quiet revolution. It's a revolution that is happening, but unlike the mobile revolution where you had a hero device in your hand and you were really aware of like how things were changing, or AI, how we can go and we can talk to a robot and you know, get answers, and it sort of blows us away. IoT is interesting because it's a quiet revolution. Because what's happening with IoT is that oftentimes we think about consumer IoT, consumer devices, and it's just a tip of the iceberg of what's happening. But in industry and out in commercial spaces and stuff, it's really changing things. And what's happened is that, as Thomas was saying, you know, Bill Gates had that vision of putting a computer on every desk in every home, and now literally we can put compute in nearly anywhere, you know, nearly everywhere. And it's really changing how we interact with the world and what we can do with computing. And as I mentioned, you know, we think about like consumer IoT, the Nest and smart fridges and things like that. And in fact, that's only about 10% of what's happening in IoT. It's predominantly dominated by commercial and industrial use cases where IoT is really making a huge difference. And in fact, today, IoT is already 3 times the size of mobile. So it's a massive, quiet revolution, and it's really changing things. In fact, nearly everyone today is building IoT. This was a couple of years ago. Over 85% of all enterprises were actually tasked with building IoT. Sort of depressing corollary to this, over 90% of those projects were failing. They were failing early, but they were failing. And so we set out to change that, you know. And what's interesting about all this is that as a developer, you know, Thomas talked about, you know, being a developer. Yeah, from a developer perspective, there's no better time to actually be a developer in IoT, because embedded engineers their demand is just off the chart. And there's really no insight here, because this is a growing market. In IoT, you know, I could spend a lot of time talking about all the different places that it's changing the world, but it really is. You know, infrastructure is becoming intelligent and being able to load balance, and you know, industry is undergoing a massive transformation, and it's increasing our efficiency and productivity in food production, industrial production. It's improving our healthcare outcomes, and it's helping us to manage resources better, and it's really creating new business models, just as the mobile revolution made new businesses and made new opportunities, and the AI revolution did the same. IoT is doing similar. In fact, one of our customers today, John Kattenhorn, is going to be doing a talk later on about how IoT is democratizing access to compute in Africa, and it's really a super interesting talk. I'm looking forward to you folks seeing that. We've got some talks from other cool customers that is going on. SAIC has built a number of cool things, but one of the things that they're going to show off today is how they do maintenance operations with IoT, how you get real-time data from sensors and you know, from boilers and submarines and things like that, and how they've created a digital twin so that you can, as you go in and maintain these things, you can be aware of what you have situational awareness. You can see how things are going. 4RD is part of John Kattenhorn's projects. And they're doing some really, really cool stuff in emerging nations in Africa. And Project Green, we're going to have Brendan Muir is going to talk about how He's using Meadow to help people save water in their homes. And Fred Barrett will be here talking about how he's using Meadow to read sensor data out in the field, and then and again create sort of a digital twin, a dashboard of data of real life, real world environmental conditions. Now, one of the things that we hear oftentimes is that hardware is hard, right? I'm sure everyone here has heard that, and it is in a way. You know, there's four main challenges with hardware today. The first is that it's incredibly expensive. What happens is that typically hardware solutions are built twice. So first, you prototype on an up-level platform like a Raspberry Pi or other single board computer, and then when it's time to go to production to deploy this in volume, then an embedded hardware design is spun, usually microcontroller based, and then you take all of that code that you wrote in an up-level platform like Python or .NET or something, and then you port it to embedded C, right? And this is insane. Nowhere else in the industry does this happen. And by the time you do get to production, security is an afterthought, right? And there's just not enough developers to build these solutions. Embedded engineering, embedded C, C++ is a very, very specialized skill set. I know, because we've hired some of these folks. And you know, it's our old CFO at Xamarin would say it's an opportunity-rich environment. Which is a nice place of saying that it's kind of a mess, right? And what happens is that when you do get to production, so you've walked through this IoT lifecycle, you're ready to go to production. How do you maintain those devices out in the field? How do you keep them up to date with security patches? How do you push out new features? How do you know if your devices are alive, right? So these are challenges that we face today, and this is what makes hardware hard. So our mission at Wilderness Labs is to make hardware development as fast and easy as web or mobile development. And in order to do that, we had to become hardware experts, right? We had to really get in the weeds and start building a lot of these things and figure out where the pain points are so that we could solve them. And what we learned here is that it's not the hardware that's hard, right? You can go to SparkFun or Adafruit and you can get some modules, you can get some sensors, you can plug them in, you can blink an LED pretty quickly, and that stuff is relatively easy. And the mobile revolution really gave us fantastic hardware, right? It's commodity cheap, it's low energy, there's lots of options. But what's difficult here is building the software, the applications that run on that hardware. It's super easy to blink an LED, right? You can, even some of the most complicated tool chains out there, and I'm looking at you, Azure, in an afternoon, you can blink an LED. And that feels pretty good. But building a production IoT solution is magnitudes more difficult. And typically, it actually takes 2 years to get to production with an IoT solution. And oftentimes, at a minimum, $100,000. In fact, Nest took 2 years and $10 million to create. And that's insane. Like, if you're an enterprise IoT developer, you don't have 100 people, you don't have 10 million bucks, and you certainly don't have 2 years to do this, right? So let's, look at the IoT lifecycle to understand sort of why this is today. And there's a bunch of different phases, and we're going to talk about this in depth after this. Leah and Adrian are going to lead a talk around the IoT lifecycle and how we can shrink that down. But it starts with a bench prototype. You blink the LED, you get some sensors wired up. Maybe you hook it up to your dashboard. Your thing's sort of basically working. It's not the final hardware. It's probably not even the same sensors. And then you move it to sort of a lab prototype where you really add everything together. And the next thing you know, you're spinning a custom PCB and you're getting that out of the field and it's sort of bodged together. And next thing is, okay, I've got customers. I want to get this out into their hands. So you spin another revision of the PCB where you take this and you make it smaller. Maybe you 3D print custom enclosure. And then finally, that goes well and you've gone through 10 revisions there. And now you need to get this into volume production, which requires another step of optimization and more spinning of PCBs, et cetera. And all in, this takes 2 years, right? And like I said, once you get out there, what happens for your maintenance story? What happens to your security story? So we set out to make this better, and we created Meadow out of this. And we did this because as developers, we were building a platform that we wanted to use, right? We are developers, our team is developers, and we wanted to take the world's best platform stack, .NET, and we wanted to make that a first-class citizen in the embedded world. And so what we did is we took .NET, full .NET, we got it working on embedded microcontroller devices, not single board computers, but real world production IoT chips. We got .NET Core 3.1 running on that space, and now we're working on a .NET 8 port. And we paid a lot of attention from the ground up around security, and we wanted to answer this question about how we field manage these devices. And what we have created is really, truly enterprise IoT for every developer. This is something that really unlocks and enables regular developers like us to build IoT. And we've built a full stack, and at the base of it, we have Meadow OS, which is effectively, you can think of this as like a mobile OS feature set that runs in an embedded environment. So we got full .NET with JIT, so you get full native speed. So it's just as fast as C or C++. We created beautiful hardware APIs, so you can talk to the hardware directly through .NET without a lot of in between. And we baked in the internet stack, the network stack through the entire OS. So when you're building .NET apps in Meadow, you don't have to think about all of the low-level networking and stuff that you have to think about when you're doing other embedded solutions. And it's got a host of features, right? SSL, HTTPS is built in, which is actually a huge thing for embedded devices. Most of the IoT devices that you see out in the world, they're not using SSL. It's all plain text. There's no security. We put a database on there. We made sure that there's real-time clocks, sleep APIs, et cetera. Like I said, this is really, think of this as a mobile OS that runs in an embedded space. And security was something that we thought about from the ground up, from hardware through documentation. And there's a pile of security features in iOS. The first is that, in Meadow. And the first is that really strong crypto-based identity services where we create a public-private key. The public key becomes the identity of the device. The private key then can be used to decrypt packages that are sent down from the cloud, and secure boot, so you don't get so people can't sideload applications onto the device. Over-the-air updates, which we're going to show today, and we're going to talk a lot about that. TPM features, true random number generation, hardware accelerated crypto, etc. Right? And the fantastic thing about this is that instead of spending a day or two trying to get your tool chain set up and then using antiquated tooling, you can use the tools that you already know and love. You can use Visual Studio, you can use VS Code, and it's as easy and as simple as .NET new Meadow app. Of course, full real-time debugging on device, and we've created this massive peripheral driver library called Meadow Foundation, which makes hardware plug and play. So we made all these really beautiful hardware APIs. So you can open up a digital port and an analog port and stuff, but we made this so you don't have to, right? So this is over 250 peripheral drivers, and it really makes hardware development plug and play. You go to SparkFun, you go to Adafruit, you grab your peripherals, you plug them in, and you just go. No more low-level plumbing. No more working with these hardware APIs. Just use them as you would anything else. This is really Legos for IoT. And then, of course, we built best-in-class hardware to support all of this, which means that you can go from prototype to production with the same code and the same hardware. These are low-energy microcontroller-based modules, and they've got a pile of flash, pile of RAM, all of the I/O, and all of the comms protocols and interfaces that you need. And this is huge. By creating these embedded modules, we actually simplify the supply chain challenge as you go to production, because we're on allocation with folks like STM and Winbond and ESP and so these are chips that it's nearly impossible to get today. The wait list or the lead time for the F7 chip, for example, is over 2 years. And by using these modules, you don't even have to worry about that. You tell us how many you need, and we're on allocation with these folks, and we can just deliver them to you. So Meadow makes the hard part of hardware easy. It makes the software easy, right? And it really, what it really does is take that 2 years and it drastically shrinks it. It takes your time to market and your cost and cuts it into a fraction of the time. In fact, we think that you can go from a 2-year production life cycle down to 9 months. You can use your existing .NET skills, and you can share your .NET code across projects. In fact, we're gonna have some talks today. One of our customers is gonna talk. SAIC is gonna talk about how they actually use the same code on Meadow as they do in their web server and on their backend. And because this is full .NET, you can use all of your favorite NuGets, right? It's fantastic. So there's really nothing else like it. And don't take my word for it. Jorge, who's very nervous, so we're all going to be very nice to him. He's going to show us. He's going to give us a real quick walkthrough of this actually working, because this sounds too good to be true, right? So Jorge, take it away.
I mean, yeah. Hi, everybody. So thank you. Thank you very much. Yeah. So Bryan really nailed all the important key points here on Meadow. We are using .NET. We're using Visual Studio, like .NET, full .NET running an IO and an embedded microcontroller. So I'm just going to give you a little glimpse of what we have here. So let's first show off. Can we show the feed on the camera? They're seeing the. Okay. So I don't know if we're seeing the camera. Are we?
No, there we go.
There we are. Okay, cool.
It'll take a minute.
So yeah. So this is the project lab, and this is just Meadow on an embedded device.
Amazing.
Yeah.
I think it's
So it's already, oh, okay, it's already zoomed. So this is already connecting to a Wi-Fi network, is getting environmental data, temperature, humidity, or pressure that we're getting here in this room, and getting this data every 15 seconds. Notice that every 10 seconds or so, this will change into a syncing indicator there. What it's actually doing is connecting to Azure and sending all this data to the IoT hub. Really, really cool thing. Really cool app. There we go. Yes, syncing, and now it's marked to done. I can even
36% humidity. Not bad. Not bad for being at the waterfront.
Yeah.
Beautiful downtown Seattle.
So if we go to our screen, can we transfer our screen, please? Desktop. There we go. Cool.
This looks a lot like Visual Studio, Jorge.
Yeah, I know. Yeah. So this is Visual Studio right here. Yeah. So this is the send environmental reading. Regular C#. It's building a message payload, which is like I'm grabbing all my latest data, my latest environmental reading. I'm creating a payload message and sending it back to the cloud. And last thing before I leave, I can show you up here. You can see this is the Azure portal for IoT Hub. You can see a number of messages used already. We're at 169, and it's just going up. So we'll keep you running until the rest of the session.
Very cool.
Cool.
Awesome. Thank you very much, Jorge.
Yeah, no problem. All right. Thanks, guys.
All right. Proof that it's real. Fantastic. Thanks, Jorge. And I'm really super excited to announce that after 6 years of really intense and difficult engineering to make this happen and writing over 1.5 million lines of code, we are shipping Meadow v1.0 today. In fact, for posterity, I have a photo of Alexi standing over by the doorway with the laptop in his hand, pushing the big button. Awesome. So Meadow 1.0 is, brings stability to the platform. We're locking our APIs, and apps now run. They're incredibly stable. These are managed apps, so memory is safe, and we've got a Meadow Foundation driver for nearly every category of peripheral on the planet. So as you go and build these things, it really is plug and play. It's like building with Legos. And we've built in secure over-the-air updates so you can maintain these devices out in the field. And today, I'm super excited to show you, Alexi is going to show us our newest newest portion of the stack, Cellular. So Cellular is in beta right now, but it's pretty rad, and this is our #1 requested feature for customers for connectivity. So take it away, Mr. Alexi. This is Alexi Christoforides, by the way.
Hi, everybody.
He's head of Meadow OS.
I'm the head of Meadow OS. I'm very excited to be here and co-announce the release of 1.0. And I'm very excited to show you our beta feature of LTE connectivity. You can see that we got our Meadow right here. And we have support for the Quectel BG77 and BG95 modems. We got some good gain antennas over here connected.
Those are some serious antennas.
Yeah. We wanted to make sure we get reception here in this brick house.
Brick.
But as you can see, the Meadow has gotten an IP address from the AT&T carrier. We are using LTE-M, also known as Cat-M1, as the connection mode. We support Cat-M1 and NB-IoT, the two low power, low bandwidth, but really low power IoT modes for sending data for small devices. Now, soon, we'll have connected on MQTT. We got message sent. And
so we just sent a message, an MQTT message over cellular network somewhere up into the Ethernet.
And you can see, off to the Ether, and you can see here we have received it. It went off to cloud MQTT.net and got received by our little node script over here that's connected on MQTT. And you can see that it's reliable, only takes about 30 seconds to connect to AT&T. And we're proud to announce the 2 modems and support for 2 modes for 1.0.
Awesome. Thank you very much, Alexi.
Thanks, Brian.
All right, that's cool. That's cool. You know, cellular is really, really cool because it unlocks a lot of use cases for putting IoT out into the field. And Fred's over there nodding. He's like, yes, I need this. I need this today. Yeah, I'm super excited about this. So this is still in beta. We've got Cat-M1 and NB-IoT up, and we're working on Cat-4 connectivity as well. And the great thing about this, so this is awesome, is that, again, the reason why this was so hard is that this isn't a lot of manual AT commands and grabbing your data and manually creating a packet and trying to send this over a modem. This is baked into the dotnet network stack from top to bottom. So all of your APIs that you're used to, you know, HTTP client, web requests, etc., those are available through this, just as if it were connected to the internet via Ethernet or Wi-Fi or anything else. And we're also working on LoRaWAN, full integration as well. And for some of you know already, we already have LoRaWAN support, but now we're baking it in so that it's seamless the way that this cellular connectivity is. So I'm really excited about this. And configuring this is super easy. It's like configuring any other network interface card on your device. You simply set the device type in your Meadow config YAML and then set up your cellular config, and you're off. That's it. It's all declarative, super easy. Don't have to worry about drivers. Don't have to worry about anything else. Just put those things in, and you're good to go. So let's talk about production, right? Because, okay, so you built this cool thing, and it's out, and you're sending it out to the field. It's connected via cellular, and it's taking data from a construction site, and it's uploading to your dashboard, your digital twin. There's some things that we got to solve there, right? And so today, I'm super excited to announce our private beta of Meadow.Cloud. Now, Meadow.Cloud is super awesome. Meadow.Cloud is a cloud-based service that offers device management. So this is where you can manage your over-the-air updates. This is also where identity for the devices is managed, as well as you can push messages out to devices just as if they were a mobile client. And we also support MQTT. And to show this off, I'm super excited to have Bryan Kim, my co-founder and one of my best friends, give us a demo. So
thanks, Bryan Costanich.
He spells his name wrong, but you know we won't. We don't hold it against him.
We'll do a poll offline and see what happens. Cool. So I have a Meadow here. It's has a purple LED blinking. It's running off a battery, so it's pretty cool. There's no hokey business here. We're going to push an update to this device and change it red. So yeah, here you can see here. That portion of the demo is over, so that's okay.
That's my fault anyway.
We have this. So this is Meadow.Cloud. We have 2 packages uploaded here. So one to set the device to red LED and one to purple, right? So now it's purple. So we'll go ahead and publish the red one.
This is cool. There's obviously there's no man behind the curtain on this.
Yeah, so this is going to take some time to marinate. So what just happened now after I push publish is an MQTT message is going to be received by the device. It's going to download the package, and then the OS is going to hand off the files to the bootloader, where it'll then restart the device and load the new application. And if for any reason that fails, the bootloader will load the previous application that was run.
How does that work? How do we make sure that we don't brick 60,000 devices out in the field?
Yeah, so it's it's not like super complicated, but we basically copy the application files over to one folder, load that, and if it fails, then the bootloader will just load it from a different area that we've copied over the previous application.
Got it. So we have full redundancy of your old application, old OS, and the new application and new OS.
Yeah,
so if things go really sideways, you can always just load the old stuff.
Yeah, and then try again. So
and try again.
Yeah, you hopefully won't break any devices. So one thing I also want to talk about is when you provision devices to the cloud.
Oh, look at that, it's red.
That's not part of it yet.
I stole thunder.
Yeah, so when you register a device to the cloud, what happens is that the device will generate asymmetric keys. The public key will go to the cloud, and the private key will get stored on the device's secure storage. And then when the device goes to authenticate to the cloud, the payload from the cloud to the device can only be decrypted by the device with the device's private key, making it super secure. I guess we don't have to talk about stuff while this is loading, but you can see that it did blink red, and it is success. Great success here.
Great success.
Great success. So what's next for Meadow.Cloud? We can go to the slides. Yeah, so next we're going to build APIs to collect logs and metrics from the devices so that we can store that data. And we can do that through HTTP or MQTT.
And this is cool because you can use an API, just use the built-in logging API, right? And if you don't have connectivity, it saves it locally. And then when it connects, you just batch upload all that data.
Yeah, that's correct. And then the OS will also do like crash reporting and exceptions for free, right? So it'll do that automatically. We're also going to build a data analytics platform so that all that incoming data, we can make sense of it with a time series database, and then we'll have a Grafana dashboard.
Visualization.
Yep, and then we'll also have event streaming so that you can gather and process the data on your own, right, outside of the cloud if that's what you choose to do. And we'll also build functionality for command and control so that you can manage devices remotely in the field for things like restarts and configuration updates and custom controls that you'll want your device to do in the field.
That's pretty awesome. So you can go to Meadow.Cloud. You'll be able to go there and change a setting for a device or for a set of devices, and it'll automatically sync.
Correct, yeah.
That's right.
Just magic. So we're doing all the stuff that nobody wants to build, but is necessary for devices in the field.
Magic.
Yeah, and it turned red, so never a doubt.
And this Kafka stream is super interesting because what that'll enable you to do is you'll have a stream of events, and because they're all time-stamped, you can actually roll back in time and then view those events moving forward.
Yeah, correct.
Yeah.
Correct. Yeah.
So, if something goes wrong in your factory floor, you can see exactly what happened. You can go back and you can audit the process, and you can say, okay, oh, I see what's happening here. A bearing must have gone out because there's all this vibration on this device, right? And then poof, the device goes up in smoke. And
yeah, you can also check on your dashboard too and slide back and see what happened in the past and look for anomalies. Yeah.
Very cool.
We'll have all the tools there for you.
Very cool.
So cool. That's Meadow.Cloud, everybody. Thank you.
All right. So this is available as a private beta today. If you want to get into this, you want to be a part of this and test this out, send us an email at hello@wildernesslabs.co. I'm super excited, and that's pretty cool. Again, no magic here, literally on a battery. Awesome. So Meadow brought full .NET to the embedded space, to true embedded hardware microcontrollers, right? But what if you need to move up the compute stack? What if you need more horsepower to do machine vision, for example? Let's say you're building an autonomous vehicle and you've got 12 visual video input feeds and you need to use all 512 GPU cores of that NVIDIA Jetson that you've got on your desk, if you are lucky enough to have an NVIDIA Jetson on your desk. What if you could use all of the beautiful hardware APIs and all of the awesome Meadow Foundation drivers on any .NET device, any device that is capable of running .NET? Well, I'm super excited to announce Meadow.Desktop. And Meadow.Desktop has two pieces to this. There's a Meadow Linux runtime, which provides Meadow APIs on Linux devices, and Meadow Windows, which is also super awesome, and we're going to talk about both of these. So Meadow Linux, as I said, gives you Meadow APIs on any .NET capable hardware. So this means Raspberry Pis, Jetson, BeagleBone, Black, etc. And this is really perfect for human-machine interfaces. And in order to do this, all you got to do is add a NuGet package. So if you're writing a Raspberry Pi application, you're writing an application in .NET that runs on a BeagleBone, all you got to do is add the NuGet package, and you're off and away. And the sort of sibling to this is Meadow.Windows, and this is going to blow you away, actually. So this enables you to use Windows as your hardware device. And what you do is you connect an I/O expander, which we're going to talk about in a second. And this is so fantastic for prototyping and for building applications, because what it means is that it takes your inner loop, your build, deploy, debug loop, to near zero. Or as Anders Helsberg would say, you hit the big button, and then you instantly hit a breakpoint. It's so fast, it's so perfect. And this offers a massive increase in productivity. And to show this off is Mr. Christopher Tackey. He is the owner of Meadow.Desktop, and he's going to give us a demo of this in action.
Absolutely. So I've got an application running here. This is a Meadow application, but you can see up at the top that we're targeting Windows.
Can we make this bigger?
We can.
My addled eyes.
Look at that.
Fantastic. All right.
So if you've used any of the Meadow stuff before, you'll see that we typically have like a Feather V2 or something here. But we now can do Windows or Linux. And what we've done is we have an I/O expander, which we'll show you here on the desktop in a minute. And then we've got an application that we're just blinking. So go ahead and go over to the overhead camera. So we've got the application's blinking this. Now you can see that we've got it wired up. There's an F7 here. It's not currently being used. We've just routed around this. So I can actually change to the F7 on this exact hardware by moving two wires. So I can just change back and forth between whether I'm running on Meadow Windows or on the F7. So this is SPI over here to an FT232 I/O expander. And so this is a USB device that gives us I2C, SPI, and GPIO for our Windows machine. So what we've got is this enables the ability to use Windows Desktop, and the speed that you're used to for hit F5, you run, it compiles, runs, gets to a breakpoint almost immediately. You can iterate really fast. It does that debug loop really quickly.
So conceptually, this now is the processor, the Windows machine is the processor, and this is the I/O expander that provides all of the SPI, digital I/O, I2C, etc. And this is an SPI display.
That is an SPI display, yes.
Awesome.
Yes, and this is using the Wilderness Labs, Meadow Foundation driver for this. So it's the exact same driver running on our desktop that we would run on the F7 or even a Raspberry Pi.
Same code.
Same exact code.
Amazing.
And so right now we're blinking. So if we come back to here, I can stop my application, make a really exciting change, and then just hit F5, and it's already running again. If you're used to doing embedded development where you're deploying to a microcontroller or something, it's usually not near that fast. So we just stop, make a change, hit F5, and it's running again, almost instantaneous. So you can do your development of drivers and even things like micrographics displays. Let's take a look at that. I'll stop this. And
so when you say displays, you mean we can actually like emulate a display on the Windows machine?
Absolutely.
Wow, that's cool. That has saved a lot of time when writing micrographics, wouldn't it? If only we had this a year ago or
so
3.
This is a WinForms version of the display interface that we use through Meadow Foundation. So this has the exact same interface as any of the small displays that you might use. So I can do prototyping and do work on my desktop and iterate on those graphics and build up the displays. Obviously, the performance on a multi-core desktop machine is a lot better than you would see on the F7, but the code is still the same. All I've done is said this is I think this is an 800 by 600 display, but you can set it to whatever size your actual hardware is, build up your displays, and then deploy it to the hardware after everything is working.
Amazing.
It's awesome.
Yeah, very cool. Like I said, if only we had this 3 years ago, maybe we could have. But now you have it. Awesome. Thank you very much, Chris.
Absolutely.
Yeah, that's pretty fantastic. Now, what if you could manage these devices from the cloud? What if you could push an update to your Raspberry Pis or your Jetson Nanos or any other Linux machine, just as you would push an update to a Meadow embedded device? Well, I'm super excited that this is actually in the immediate future. This is what we're working on right now for Meadow.Cloud. We want to bring that same management, that same maintainability to any device in the field. And this was, by customer request, the ability to maintain really any device out in the field is such a huge, it's a real need, and we're really excited to be working on this. And this means not just OS images and app updates, but also deploying via containers. And if you've got other embedded devices out in the field, we'll also support MCU boot. So if you're already using MCU boot today, you can simply migrate over to Meadow.Cloud seamlessly, and you're set. So I'm really excited to be bringing Meadow.Cloud to all of these devices. So I want to talk about the other piece of this, the sibling to Meadow.Desktop, which is Meadow Linux, right? And we talked about how Meadow Linux enables Meadow to run on any Linux device. And what's interesting about this is that if you look at a lot of these devices, and let's say you're building an HMI display, a human machine interface, and this is something that displays information about a machine that you might be working with. So you might walk up to a massive industrial printer or something, and you get a display, and it shows you some things happening on that device. Now, the best way to do this is to pull up WPF or pull up Maui or pull up Avalonia and use all of those declarative languages to build your UI and build your application. This is really the productive way to do this, right? And so what we've done is that we have made Meadow work with all of these other UX platforms, right? So now you get best of both worlds. You get Meadow hardware, you get Avalonia UX APIs, and you're up and running. And I'm super excited. We have Mike James, the CEO of Avalonia, has flown all the way over here from London, and he's going to give us a demo, which I'm really excited about because really hot.
Brian, it is exciting to be here.
Yeah.
So Avalonia UI, as Brian mentioned, is a UI technology. So it allows you to build applications in C# and XAML for Windows, Mac OS, Linux, iOS, Android, and WebAssembly. So it's one project that runs everywhere. And it's inspired by WPF. So if you've ever built a WPF application, you're already an Avalonia expert. And one of the most common use cases we find is businesses need to build embedded UIs. So one of our big customers is Schneider Electric. And they had a WinForms application, and they ported it over to Avalonia to run HMI little embedded Linux devices. So it's a good opportunity to show people how that works and what the development experience is like, and yeah, see it on a device. So we already have the screen showing, perfect. So the development experience is literally just like WPF. So we have some XAML here. If you've ever written any XAML, this will all be pretty familiar to you.
Can we switch over to the document camera just for a sec so the streaming folks can see how cool this is?
Yeah, so this is the application running on the Pi.
Ooh, no.
Well, it's a little washed out there.
Here we go. Look at that. That's pretty awesome.
Yeah, so this is a Raspberry Pi running Raspberry Pi OS Lite. So there's no desktop environment, and we're pushing pixels to the display using the Linux frame buffer. So the really nice thing about Avalonia is how light it is. We can run on some really low-powered devices. So Schneider Electric, for example, are running on a 500 megahertz 32-bit ARM processor that was released in 2005. So this isn't a powerful device by any stretch of the imagination, but they're still able to get smooth animations and a performant application. And the development experience is really sweet. You just hit F5 and you can build your application and test it and see how it looks on your machine. If you're using Mac OS, Windows, or Linux, it all just works. And then once you're happy with how it looks, you can deploy it to your embedded device and check it out there. Now, the magic...
That's a cool UI, by the way. That'd be really difficult to build for an embedded device if you didn't have an up-level
Right,
platform.
you would probably need to jump into something like C++ and Qt, which is, that's, for a .NET developer, that's a big learning curve.
Yeah, it's a big jump.
Yeah. So the magic here is really happening in this app class. This is kind of the merging of the two worlds of Meadow and the Meadow Linux and Avalonia. And if we jump down to the bottom...
Can we see that app signature? This is really interesting. So we have Avalonia Meadow application,
right,
and it's running on Linux, and the type is the hardware is the Raspberry Pi, which gives us all the pinouts and all of the fantastic Raspberry Pi goodness, right?
Exactly that. Now, this device is just using emulated hardware, and we've got these abstractions here, these interfaces that come from the foundation. So I didn't have any of the devices when I was building this app. I was sat on the sofa just coding whilst the wife was watching TV, and I could make that work without having to have all of these electronics around. And all I need to do to change it once I've got the devices is come in here and change this Boolean value to false. Oh. And now I can redeploy, and if I've got the hardware connected, it's just going to work. So this is a fantastic development experience.
That's pretty fantastic, and this simulation stuff is cool. So you just simulate your sensors.
Exactly that. So yeah, that's Avalonia running on embedded.
Woo! All right, very cool. Thanks, Mike. Awesome. That's so cool. I mean, this changes the game for building HMIs. You really do get the best of both worlds, right? You get the up-level development platforms that we've been used to for so many years of WPF and now Maui and Avalonia, and you get all the beautiful Meadow hardware goodness and being able to manage these devices out in the field, send updates, etc. So as we were building hardware and as we were solving these challenges that our customers have faced with hardware, we came up with some cool reference designs. We came up with these IoT accelerators. Now, these IoT accelerators enable you to basically start running, right? And these are reference hardware. It's all open source, and these are designs that already solve real-world applications. and give you a bunch of real-world sensors, real-world hardware. And you can take these and you can pull these apart and you can use them in your own designs. And they're, like I said, they're fully open source. And we released 2 of these, Clima, which is our weather station, and Project Lab, which enables you to prototype immediately, right? Instead of going and breadboarding or soldering, you basically, this sort of octopus picture here is Project Lab. And you notice that we've just plugged sensors in. We've plugged in peripherals. And no longer do you have to make this breadboard mess. No longer do you need to have wires everywhere. And you can't figure out why it works. And it happens to be because the breadboard that you got off of AliExpress is just not super high quality, and there's a ground issue, right? And you got to wiggle the wire and get it to work. You don't have to do that anymore. You don't have to solder. You don't have to have any real manual dexterity. You simply plug hardware in and you go. And this is really fantastic because this drastically shortens the prototyping period. This really takes all of that time that you would spend wiring things up and stuff and just makes it instant. So in an afternoon, you can get to a bench prototype with a Project Lab board. And I'm super excited. We are launching the Project Lab V3. Now, the Project Lab V3 board adds a bunch of new stuff. So it already had a bunch of really cool things. It had it had Grove connectors. It has the microbus slots. So you can, I think there's something like 3,000 microbus clickboards. So any kind of peripheral that you want, you can just plug into this microbus slot. Grove is from Seed Studio, and this has analog inputs. It has digital I/O. It has a serial UART, and it also has the Adafruit and SparkFun Stemma QD/Quick connector, so you can grab I2C devices and plug it in. And the board even has an I2C accelerator on there, so you can actually run I2C devices over long cables. It has RS-485, so you can do industrial sensors, places where you might need Modbus, or you're plugging in fancy industrial sensors that use RS-485 voltage. All makes this super easy, and of course, it also has HMI features. There's 4 buttons to serve as a directional pad, and we added in this new version a massive display on the Project Lab V3. It's also core compute module based. So the last Project Lab board was used the Feather interface, and now we've moved it over to the core compute module. And again, this is all open source. And Project Lab V3 will be shipping in July. And we've got this fantastic carbon edition. So if you make sure to order today, because these are going out in batches, so we're sort of first in, first out. And I'm really excited about this. Now it comes with an awesome enclosure, which is a carbon fiber 3D printed enclosure, and it's got buttons and very cool. So Project Lab is really awesome because, like I said, it drastically reduces your time to market and your production cycles here. We've also got some updates for Clima. So Clima was our first IoT accelerator, and Clima is our weather station. This is an industrial weather station that provides, it's got an anemometer, it's got a rain meter, it's got a wind gauge, also does air quality and temperature, pressure, humidity. And there's a sample a reference app that does cloud sync to Azure, and also, I think, open weather. So you can actually deploy this out around your house or around town, and it'll upload to open weather, so you can be part of the open weather community. And it comes with a Maui app, a companion app, as well as a BLE API, so you can connect to it if you're next to it. You can connect to it and see all the real-time data via Bluetooth, or you can connect to the cloud and see the data that you're uploading. And I'm excited to announce Clima V3. So this is the latest version, the latest iteration of Clima. This is also core compute module based, which is great because as you're going to production and you're building your own designs, you can look at the design here. You can look at this all open source. You can see how we've done this. And Clima V3 adds some new features. It's got a really high quality SCD40 humidity sensor. And if you've ever worked with these, you'll know that these are probably the best CO2 sensor on the market. I think this sensor costs like $30 individually. So this is a really awesome CO2 sensor. It also adds GPS, so you can just sprinkle these out and about, and they know their location. You don't have to manually configure them, and set their location and whatnot. They just pick it up from the quantum magic of GPS, GNSS locationing. So super excited to announce Clima v3, and these will be shipping next month as well. And we also have a kerning problem, a text overlay problem here. We also excited to announce a GNSS tracker. We actually created this originally for one of our customers, SAIC, who are using these in theater operations. And this provides real-time battery-operated GPS tracking and environmental tracking. So it's also got environmental sensors built in, temperature, pressure, humidity. And again, this is another reference design. So if this is something that you're looking to do logistics tracking, GPS tracking, etc. Check this out. There's a companion app. It's very cool. And again, all open source. Shows you how to do this, how to make this your own. And you'll notice that all of these designs share something in common. If you look at this, there's these cool modules. So you see these squares here. What happened is that we're building these things, and we thought to ourselves, man, we're solving the same challenges over and over and over in hardware, right? What if we could reuse hardware designs like we did in software? What if I could grab the hardware equivalent to a NuGet package? Because most IoT really is, from a hardware perspective, it's really the same. Like most IoT solutions out there are some minor deviation of 5 or 6 designs from a hardware perspective. But what really makes it magic is the application that's running on there, the customization, the integration in your infrastructure, in your backend, etc. So what if we could spin hardware super quickly by just grabbing the hardware NuGet package, if you will, and create these custom PCBs? So we did exactly that. We created these core compute module add-on modules, and these solve common use cases in hardware. So you're using a core compute module, and you need USB, and you need power, and you need boot reset, right? Because you need to be able to deploy your application during development. Simply grab the USB-C module, drop it on. There's great documentation for this. And tomorrow, actually, in day 2, I'm going to be showing, there's a workshop on how to use these. So we're going to design a CO2 sensor. This is a mobile CO2 sensor. It's very simple. It uses a core compute module, a USB-C add-on module, and it's got the CO2 sensor and an LED. We're going to show you actually how easy it is to build this in a home lab with nothing more than some masking tape and a hot plate. So very cool. And this uses these core compute add-on modules. And these come in a number of different flavors, and we're working on additional ones here as well. And the great thing about this is that you can use these in your design. These will get you, again, this will shorten the life cycle to production. Use these, drop these into your design as you get through field prototype and early product beta. And when you're ready to go to volume production, you simply take these designs, decompose them, and put them in your circuit and integrate them all in one. So again, really want to get you out to production faster and easier. And the great thing about these is these are all fully tested with the core compute module. They've gone through a number of iterations, and they are very well documented. They're fully open source, and we've designed them so they've got these large castellated SMT pads, so you can drop them in. Again, you can do this at home, and it's very easy. It's very difficult to make a mistake with this. And these will be shipping next week. They're actually already into the store, store.wildernesslabs.co. We need to publish them. And so those will be shipping next week. Super excited about those. And again, check in tomorrow. We're going to talk about how to use them. So I'm really excited to be here with everyone. Stoked that you're here, and hope you'll stick around. We've got an exciting 2 days of content. It's really action-packed. So after this, we're going to go into an emerging trends in IoT panel hosted by Leah, and it's going to bring in a couple of our customers, and they're going to talk about all of the interesting things that they're seeing in IoT. And actually, this is going to be a really interesting panel. And then we're going to see some customer stories, folks that are building on Meadow, and Glade 2D. What is that? Oh, that sounds interesting. Maybe we'll talk about it in a sec. And then afterwards, we're going to have a reception. And tomorrow, we're going to do a deep dive into all this from a technical perspective. This is Meadow University, day 2. We're really going to dive into all the different features of Meadow OS and the hardware APIs, Meadow Foundation, get you up and running. And also Meadow.Desktop will show you how to get that, how to start using that today to really drastically reduce your time to deployment. And as I mentioned, this PCB workshop, and then we're going to finish it up with a fireside chat with myself and Brian Kim. So thanks for everyone coming here today. I'm super excited about this. Oh, we got one more thing. Actually, do we have one more thing? I don't know where it went. Oh, it's here. It's just not plugged in. So the Mojang guys, Mojang, for those of you who don't know, is the company that has created Minecraft. So the Mojang guys were hacking around on Meadow, and they did something really, really cool. They're like, this is really fantastic. What if we created a game engine that runs on Meadow that enables you to use all of your C# skills and write games that run on this hardware? Because it's low energy, you can run it off a battery, you can make it handheld, it's all very small. And so and Justin Johnson, who's head of I'm going to screw up his title, Program Head Manager, Poobah, Grandmaster, Mojang, something like that. So he's here today, and he's actually going to talk. And they've created this really fantastic 2D gaming platform for Meadow. And if I can get the document camera here, I can actually show you this in action, maybe. So this is Glade Invaders. Yep, that's right, Glade Invaders. No IP infringement here. Serious Glade Invaders. I don't know what button to want to do. There we go. All right, very cool. So this is the built on Glade 2D, and it's pretty awesome. So he's got a talk on this. He's going to show you how to use Glade 2D to write games for Meadow. And as a celebration of that, we created this fantastic little gaming device called Juego. And by the way, if you ever have a challenge naming something, it's really easy. You just go to the Spanish dictionary and you find the Spanish name for it. Juego is game in Spanish. So this is a handheld gaming device. And that's going to be in the store next week for purchase as well. And that's just a fun little piece of hardware. But again, all open source and can show you how to do this. And heck, maybe you'll run a Kickstarter and build the next fun gaming device. All right, awesome. Thanks, everyone. I'm really stoked that you're here, and I'm really excited that we got to do this in person. And hello to everyone on the streaming internets, online live television. Welcome to DevCamp, and I can't wait for the rest of the sessions. So thank you very much.